All right, so let's talk 2-3, molarity. So the first question talks about why using molarity, the mathematical way to express concentration, is better than using the terms dilute and concentrated. The terms dilute and concentrated are very vague, meaning we could have different interpretations of what dilute actually means or what concentrated actually means based on our own perspective. Molarity is very mathematical. It tells us how many moles of solute, stuff dissolved, in 1 liter of solution. So it's an exact value. We can compare numbers easily, and there's no bias in there. There's no interpretation. Number 2, the molarity of a solution indicates the number of moles of solute. So if I'm making salt water, how many moles of salt, for example, do I have dissolved in a certain volume of solution? U-M-E. Usually the volume's 1 liter. So a label reading 5M, 5 molar HCl, tells us that in 1 liter of this solution, so if I had a beaker and in my beaker is 1 liter, I know that it contains 5 moles of HCl and all the rest is water. So it tells me how much solute, HCl is my solute, is dissolved in my volume, which in this case is 1 liter. If I see 5 molar, or 5M rather, I read it 5 molar, just like your tooth. You don't really say 5M. So whenever you calculate molarity, it's always moles divided by liters. So you're going to look for something in the problem that tells you moles, not mass, moles. So if I see 4 moles, I put it on top. If I see liters, I put it on the bottom. And then I got a number on top, number on the bottom. What do? I just divide. So on your calculator, type in 4 divided by 2.5, and what do you get? Oops, erase all that. There we go. We get 1.6. Now, what's the unit? Well, we could write 1.6 moles for every 1 liter, or we can do what the chemists do, and it's abbreviating this. It's 1.6 M. And that's usually what we stick on the label. 1.6 M means if we had a liter, it would contain 1.6 moles. In this example, we have 2.5 liters, so it's going to contain more than 1.6. It's going to contain 4. But the ratio is still the same. 4.0 to 2.5 is the same as 1.6 to 1. That's the simplest problem. I give you moles and I give you liters, you just divide the two. Now this is a little more complicated because it gives you grams, not moles. Remember, you need moles on top. So if you have grams, you can't just throw it on top because it's not moles. You've got to do a gram to mole conversion. So you're going to take grams and put it down here because you want grams to cancel. And then you're going to put 1 mole on top. You're going to look on the periodic table. Now, I was nice and I gave you the molar mass here. If I didn't give you this, you have to look on the periodic table and add up 1 magnesium, so it's 24.3, 1 sulfur, 32.1, and 4 oxygens, 16.0 times 4. Now, if I didn't give you 120, you'd have to do that, add them all up, and you would get 120. But I was nice. I gave you 120. So, 100 times 1 divided by 120.4. And if you do that, you get we'll round to the 10 or the hundredths place, 0.83 moles. Now I have moles and I have my liters of solution. So I can put 1.3 liters on the bottom and I can put my moles on top. So this whole first step was just about getting from mass to moles. Once I have moles, it's easy now. I just divide moles by liters. So 0.83 divided by 1.3. And what do I get? 0.638. You can round 0.64. How's that? Again, moles and liters don't cancel. They're not the same unit, so they don't cancel out. So we could rewrite it as moles, 0.64 moles in every 1 liter. So if I have a beaker and it's got a volume of 1 liter, I know inside there is 0.64 moles, or 100 grams. If I had 1.3 liters, but 0.64 moles in every 1 liter of solution. The other way I could write it is 0.64 instead of moles per 1 liter. I could write 0.64 big M. Now, 4 steps involved in making a solution with a specific molarity. First thing you do, you use a volumetric flask. And in your volumetric flask, you're going to have one line on the neck. You're going to fill it about halfway. Put some liquid in there. Then you're going to add the correct amount of solute. For instance, if I was making this, I would dump in 100 grams of magnesium sulfate. Then I would swirl it to dissolve. And then I add more water until it reaches that point on the neck, that line on the neck of the flask. So put your a little bit of water in. Don't worry about exactly halfway. Just dump some water in. Add the correct amount of solute, swirl it, and then keep going up until you hit that line. Now, imagine you wanted to make a 1 liter solution of a 1 molar solution of NaCl. So it's saying I want to put, when I'm done, I want to have 1 mole in 1 liter. What mass of NaCl should we add? Well, what's the mass of 1 mole? If I'm going to make a 1 molar solution, I'm going to put 1 mole in 1 liter. So what is 1 mole equal to? 1 mole of Na is 23.0. We get that from the periodic table. Chlorine, 35.5. Add them together, 58.5 grams. This is the molar mass, or the mass of 1 mole of NaCl. So that is what I have to add to my flask. If I do that and fill it up to the 1 liter mark, I have a 1 molar solution.